I will be talking about the history of stars. Stars are massive balls of burning hydrogen that emit light and heat. Stars can live up for a very long time, in some cases billions of years. Stars are born from clouds and dust in space. Gravity pulls clouds in to make one big cloud. It is called a big space dust cloud. When it is hot enough for a reaction to start, a spherical cloud sort of circle begins to appear, and it has to be hot enough for nuclear reactions to take place, for nuclear fusion to take place for it to happen. And this is called a protostar. Our sun is halfway through this stage and will continue for around 5 billion years. So a long time. Now, there are two options for when a star inevitably dies. One is for medium weight stars, which then go down a sort of smoother death, but for heavyweight stars it's another sort of death, and the deaths depend on the weight and size of the star. For a medium weight star, which is like our sun, you have the sun, which will, in the number of years to come, so 5 billion years, what will happen is that it will swell to a red giant, which is massive. And the red giant is so big it will swallow all the inner planets. So the Earth and Mars. So the Earth will be swallowed by the big red giant. Then the huge red giant shrinks to be surrounded by outer shells of gas. And this is the start of the planetary nebula, which is a sort of nursery for stars, and this is called the protoplanetary nebula. Now, the core cools and contracts to become a white dwarf. It has a density of 1,000 times greater than any matter on Earth, and this is the death of a medium star. So this is the death, and that is quite literally it really for a medium star. However, for a heavy star, this is where the fun begins. For a heavyweight star, the star will swell up to be a red giant, so it will swell to a massive size, and it is a super red giant, so it is bigger than a red giant, and it is massive. A red supergiant is gigantic and huge compared to a red giant, but instead of shrinking into a white dwarf, it lets out a ridiculously massive explosion called a supernova. And a supernova is the universe's biggest explosion, and it's massive. It's so big that scientists say that if a supernova occurred, then what would happen? So this is a supernova in our galaxy, the Milky Way. If a supernova occurred, then as light comes from the sun, scientists say that a secondary sun would form. It is so bright that a secondary sun would form. then the supernova can turn into two things depending on the size and weight of the star before it exploded. It can turn into either a neutron star, which we'll discuss a bit later. This is called, or a black dwarf is what it's called, or a black hole, which is what happens when a star is really, really heavy. Now, a neutron star is basically just it's called a black star or a black dwarf, and it is a star that emits very little light, and it is very dense, and it emits very little light, and it is a dying star because it doesn't do much except for just a massive ball of very, very dense mass and decayed matter. Or if a supernova occurred, then a black hole could appear, and a black hole is a star that is heavy enough to become a black. Is basically 10 times the mass of our sun, and you can only see a black hole on the effects they make on the surroundings, so you can't actually see a black hole. But say we had light, it would bend around, so that's how scientists see black holes. And also galaxies like this one, which is a galaxy, will be sucked in, and other planets or stars. So that is a black hole. And there is theories of from scientists that there are other dimensions inside a black hole and other universes inside a black hole. So if that is true, then yeah, there are other universes inside a black hole, which could be true. We don't know. And that sort of concludes the whole history of stars. I hope you've learned a lot, and that is the end. Alright, see ya.